Hey everyone, it's Mr. Canfield. This is the first of 2 review papers for Chapter 9. So here we go. Use DEFG for items 1 to 3. So I actually want to change this first question. I thought I did before I printed it and I just didn't. We're going to write EF and DG. So what describes the relationship between EF and DG? So if I'm looking at these are my options. Are they perpendicular? No, they look parallel. We'll inspect that a little bit more later. Do they bisect each other? Well, no, they don't touch. Are they congruent? So those are the 2 things we should check out. All right, so let's check out to see if they're parallel. Well, for parallel, I would need to use slope to figure that out. If they have the same slope, then they're parallel. From E to F, it rises 1, 2, 3, 4, 5, and runs 5. Rises 1, runs 5. From D to G, it rises 1, 2, 3, 4, 5, runs 5. They have the same slope. They are parallel. Additionally, these little right triangles that we built, the legs are the same. That means the hypotenuse will be the same as well. I don't know what the hypotenuse is, but it will be the same. And so that means they're congruent, because that hypotenuse is actually the side. The little extra sides I drew aren't the side. It's the one that's actually there that's the side. All right, now let's talk about this quadrilateral, what kind of quadrilateral this is. Well, it has parallel sides. I wonder if these other 2 sides are parallel. Well, look, they're straight up and down. They're both straight up and down, and they're 1, 2, 3, 4 long. Okay, so the sides are 4 and 4. I don't know what these sides are yet, but they look like they're more than 4. I don't think they're 4. So I couldn't call this a rhombus because I don't think all the sides are 4. You know what? Let me double check that really quick. 1 squared plus 5 squared is equal to c squared, which is that diagonal piece right there that we're missing. So it's 1 plus 25 is equal to c squared. So c is equal to the square root of 26. So we're going to add them up and then take the square root. And the square root of 26, I don't have a calculator with me, but it's 5.1. Pretty sure. So it's 5.1. Okay. So, and that side is 4. So it's definitely not a rhombus. But those have the same side length and those have the same side length. So we got 2 pairs that are opposite each other. Like these opposite sides are parallel and congruent. These opposite sides are parallel and congruent. We called that a parallelogram. So this is a parallelogram. The sides aren't all equal. It's not a square. And those definitely are not right angles. You can just tell. And it's not a trapezoid because we have parallel and parallel. Trapezoid needs 2 sides to be not parallel. So the next question says, what is the perimeter of the quadrilateral? So I found that the one side is 5.1. So we got 5.1, 5.1, 4, and 4. Oh, wait. We know all the sides. If you're like, how'd you get 4? It's vertical. It's following the grid. You can literally count it. You can't count diagonal stuff because then each kind of space you move, it's not 1. It's a different length since it's not following the grid exactly. So if I add those up, we'll get our perimeter. See, that's 8 and then 10.2, so I got 18.2 when I added them up. Sweet. All right. Number 4, what type of triangle is triangle ABC? Select all that apply. So looking at this kind of looks like a right angle to me. Not 100% sure, but it looks like a right angle. So I'll put a little question mark there. Maybe it's a right angle. Well, the way I can check that is by looking at their slopes. So if I look at the slope from C to B, it looks like it goes down 1 and then 1, 2, 3 over. Down 1, 1, 2, 3 over. That's down 1, 1, 2, 3 over. Rise over run. So that's BC. Let's look at BA. From BA, you can go either way. Let's start at A. 1, 2, 3 up, and then 1 over. Hey, look. These slopes are opposite. and they're also flipped, which is reciprocal. Opposite reciprocal slopes, that means they're perpendicular. That means this is a right angle. That means this is a right triangle. Now I got to figure out, is it an equilateral, isosceles, or scalene right triangle? Word of just caution, on an equilateral triangle, all the angles are the same too, since all the sides are the same. All the angles are 60 degrees. It's not possible if it's a right triangle. You don't need to know that to do this part. Because all you got to do is go, well, let's see, I went up 3 and over 1, 3 and 1 here, and this is not 3 and 1, this is 1, 2, 3, 4, and 2, which is going to have a different final answer than the 3s and 1s. But these two are going to have the same diagonal, so I know it's an isosceles triangle. Now it asks for the area of ABC. Well, if only I could find out those two lengths. I don't care about this one. I just care about these two because the area is 1/2 base times the height, and those are the same. So let me find them. They're going to be 1 squared plus 3 squared is equal to c squared. So that's square root of 10 is equal to c, which is about 3.1. So now when I go in, I'll do 1/2. Base is 3.1, height is 3.1, and don't care about the hypotenuse. This gives me the answer, and I got 4.805. All right, onward and upward. Or onward and downward, I guess. Okay. Which of the following would show that quadrilateral JKLM, show the diagonals of quadrilateral JKLM on the coordinate plane are congruent? All right, let me just draw some random quadrilateral. Here's JKLM. That's how that works. You always write it in order. Wherever you start, you just have to go around in either direction in order. So show that, what happens if we show JL is equal to KM? Well, JL is this and KM is that. Those are the diagonals. If those are equal to each other, they would be congruent. There we go. That's what that question is asking. Let's look at B. Show that the slope of JL times the slope of KM is equal to -1. So this is something I haven't addressed with you, but what this means is if I took these two slopes and multiplied them together, I get -1. That only happens with perpendicular slopes. If they're not perpendicular, you won't get -1. So if I take this times this, I get -1. If I take this times this, those are parallel, we don't get -1. And it turns out it only happens when it's perpendicular. So this is another way of saying perpendicular, which is not what that one's saying. What about show that the midpoint of JL is the same as the midpoint of KM? That would mean that these two things, it's like that and like that. It would say that they're bisecting each other, that they're cutting each other in half, because they're both meeting at each other's midpoint, which is not not what this question's asking about. We didn't really talk about that. I probably am not going to put that on the test, but I don't think it's a far reach from what we've been talking about. Excuse me. Sorry about that. Show that the slope of JL is the slope of KM. If they had the same slopes, that would mean they were parallel. It doesn't mean anything about if they're congruent or not. It just means that they would be the same direction. Ooh, double excuse me. Okay, on to the back. Yeah, it's not too dark on the other side. Okay. Which of the following would show that quadrilateral PQRS is a parallelogram? So I think there's a typo in this first question here. I think this is supposed to say PS and QR right here, like the same as those. So PQRS, PQRS in that order. If I want to show it's a parallelogram, well then I would need PS, which is this one right here, to be parallel to QR, and I would need them to be equal to each other. Additionally, I need PQ and RS to be parallel to each other, and they also need to be equal to each other. So we want this one, we want this one. We don't care about their midpoints. Although I do believe that happens in parallelograms. So maybe that, no, I think there's other situations. I could be wrong. All right, can't feel dumb. I think that is a situation that happens in parallelograms, but it wouldn't be necessary to show it's a parallelogram. Let's see. Show that the slope, so show that we have perpendicular diagonals. Let me just I think this example should work. Those are not perpendicular, so we don't need that. All right, what is an equation for the circle with center 4, 8 and radius 2? So if you're not sure how to do these last few, I recommend going and watching my video on circles. It's pretty short and I explain it all pretty well. So 4 and 8, we use the opposite to those. So x minus 4 squared plus y minus 8 squared. And then the radius is 2, so we square that and we get 4. Next question is pretty similar. Just instead of giving us the numbers, we have to find them. So here it looks like my center is -4, -2. So that's going to turn into x plus 4 squared and y plus 2 squared. And my radius here is 1, 2, 3. So 3 squared is 9. There we go. Let's go to our next one. It looks like our center is 3, 2. So that'll be x minus 3 and y minus 2. Don't forget the squareds. My radius is 1, 2. Radius is 2, so 2 squared is 4. 4. All right, one more question. And really the only curveball on here. So is the point -2, 11 on the circle with radius 5 and center 2, 13? So if first let me write the equation. X minus 2 squared plus y minus 13 squared is equal to 5 squared is equal to 25. So there's a couple ways we could do this. One of them is we could find the distance between -2, 11 and 2, 13. So distance is equal to, let's see, x2 minus x1 plus y2 minus y1, which is 13 minus 11 squared. So is that 4? So then 16 plus 4. So I got square root of 20, which is approximately equal to 4 point blah. I don't have my calculator on me right now, but is 4 point blah equal to the radius? Because that's what the distance from a center to a point on a circle should be, the radius. Is that 5? No, so it's not on the circle. Another way to do it is you can plug it in here and check. You can plug in -2 for x, plug in 11 for y, and see if that's 25. We get 20. Is 20 equal to 25? No. So if you're like, hey, that's like the same thing. Yeah, it's just 2 ways to do the same problem. So that's the first review paper. Hope it was helpful. You know where to find me if it wasn't. Bye.